Assalamualaikum and hi everyone. Today we are going to learn about subtopic 5.2 liquid. There are four learning outcomes for this subtopic. At the end of this subtopic, you should be able to relate the properties of liquid to intermolecular forces, molecular arrangement, and molecular motion in explaining the shape and volume, surface tension, viscosity, compressibility, and diffusion. Next, you should be able to explain what is the vaporization and condensation process. Then, define what is the vapor pressure and boiling point. Lastly, you should be able to explain how the boiling process occurs. There are 5 properties of liquid. The first one is volume and shape, compressibility, diffusion, surface tension, and viscosity. For the volume and shape, liquid has a definite volume but not a definite shape. So, liquid conforms to shape and volume of its container. Liquid also has moderately highly fluidity. This is because the molecules are arranged closely but not rigidly, as you can see in this animation. This means that the molecules still held together by intermolecular forces, but they're able to move freely. This is an example of liquid conforms to shape and volume of its container. Next, compressibility. In liquid, the particles are packed closely together. As you can see in this figure, when pressure is applied, so very little free space between the molecules. Thus, we can compress only slightly or liquid are almost completely incompressible. The next properties of liquid is diffusion. Diffusion is the movement of fluid from one fluid through another. Diffusion rate of a liquid is much less than gases due to the liquid molecules are closely packed and have a lower kinetic energy. This is because there are stronger intermolecular attractive forces between the liquid molecules compared to gases. This is example of diffusion process. What happened in the first figure? We have a water molecules as a solvent in a conical flask. Then a crystal of dye is placed in the water. Next, what happened? The diffusion of water and dye molecules occur. Lastly, water and dye molecules are in equilibrium, means the distribution of these molecules are equal. Can you give me an example of diffusion in everyday life? Yes, good try. Have you ever wondered why the fragrance of your perfume spread all over? Correct. Happens due to diffusion. Another application is tea bags. When we put tea bags into a cup of water, it automatically mixes in the whole cup of tea, and this also happens due to diffusion. Consider this animation. There are two areas, which is high concentration area and low concentration area. Particles from the area of higher concentration will move to the lower concentration, continuing until equilibrium achieved. This is what happens in diffusion process. Surface tension. The definition of surface tension is energy required to increase surface area of the liquid by a unit area. Consider this diagram. There are two types of particle at the surface and particle or molecule within a liquid, or we call it as interior molecules. Interior molecules attracted by others from all sides, but molecule at surface only attracted from below and sideways. So, this intermolecular attractive will pull the molecules into the liquid, cause the surface to stretch and tighten. One of the factors that affect the surface tension is intermolecular attractive forces. The stronger the intermolecular attractive forces, the higher the surface tension. This is an example of surface tension. Because the existence of surface tension, it will prevent paperclip from submerging. Viscosity. Viscosity is a measure of fluid's resistance to flow. Means, the greater a liquid's viscosity, the slowly it will flow. As you can see in this animation, the liquid has high viscosity but low flow rate. While the lower a liquid's viscosity, the faster it flows. As you can see in the second animation, this liquid has low viscosity but high flow rate. Viscosity depends on, the first one is intermolecular forces. The stronger the attractive forces, the higher the viscosity. The second one is temperature. Viscosity decreases as temperature increases. Next, vaporization and condensation process. Vaporization is the process in which a liquid is transformed into a gas through a surface, while condensation is the process in which a gas is transformed into a liquid. How the vaporization process occurs? According to the kinetic molecular theory, liquid molecules gain energy and move quite freely. Each molecule possesses a different magnitude of kinetic energy, but some molecules have a relatively high kinetic energies compared to the others. When molecules at the surface have sufficient kinetic energy to overcome the attractive forces that bind them, the molecules will loosen themselves and be evaporated off into a gas. There are several factors that affecting the rate of vaporization. The first one is surface area. The larger the surface area, the higher the chances for the molecules to escape from the surface, hence vaporization rate is increased. Second one is temperature. When temperature increases, the number of molecules that have enough kinetic energy is also increased and escape to form a gas. So, vaporization rate is increased. The third one is intermolecular forces. The weaker the intermolecular forces, the higher the rate of vaporization. Condensation. How the condensation process occurs? According to kinetic molecular theory, when the temperature is lowered, the kinetic energy of the molecule decreases. So, the molecules getting closer and cannot overcome the intermolecular forces. Means more vapor molecules may strike the surface of the liquid and be captured there. Therefore, the gas will condense into the liquid. Vapor pressure. What is vapor pressure? Vapor pressure is the pressure exerted by vapor in equilibrium with its liquid in a closed container. Consider this diagram. The first diagram shows a molecule in a liquid vaporized. Then, molecule enter and leave liquid at the same rate. In this situation, molecules of vapor and molecules of liquid are in a dynamic equilibrium. Volatile liquids like acetone have high vapor pressures at room temperature, while non-volatile liquids have very low vapor pressures at room temperature. Okay everyone, to have a better understanding about what is a vapor pressure, let's watch this video.
Hi everyone, this video is going to be all about vapor pressure and the way it relates to the strength of intermolecular forces or attractions between molecules and the boiling point of those substances. So on the screen now I have two quote-unquote capped jars, and they both contain liquids, and both liquids are at STP, which if you remember stands for standard temperature and pressure. And if you look on table A of your reference tables, you'll note that that means 273 Kelvin or 0 degrees Celsius and 101.3 kPa or 1 atmosphere. So what we know about these liquids is they're both at the same temperature, and the outside atmosphere is both pushing on them as with equal amounts of strength. When we talk about vapor pressure, since another word for vapor is gas, what we mean is the pushing force exerted by a gas that's sitting on top of a liquid. Now, I didn't tell you the identity of these two liquids, A and B, but let's just pretend for a moment that A is acetone, or nail polish remover, right? If I open the lid on this jar, you would all of a sudden get this huge influx of gas molecules into your nose that creates that unpleasant smell that you get when you open a bottle of nail polish remover. What that tells me is that on top of this liquid that we can see sits a layer of invisible gas that's bouncing around inside this jar, exerting a particular amount of pressure. So it's this section of gas that sits above the liquid that's responsible for creating the vapor pressure that we associate with something like acetone. Now over here on the right, let's say liquid B is something a little bit less stinky. Let's just say it's plain old water. If you open the cap on this particular jar, we know eventually water would be able to evaporate, which means there is some quote unquote hidden gas above our liquid, but certainly not as much as there was for our acetone. So when we're comparing liquids A and B just based on these drawings, what I would say is that liquid A has the higher vapor pressure, or VP, simply because it has more molecules in the gas phase sitting above its liquid. Therefore, B has the lower vapor pressure.
Okay everyone, in a simple words, vapor pressure is a pressure that causes by the vapor molecule, right? Next, boiling point. What is the definition for boiling point? Boiling point is the temperature at which the vapor pressure of a liquid is equal to the external or atmospheric pressure. This is an example of boiling point of water at different height. As you can see, boiling point of water at the sea level is 100 degrees Celsius, and then it becomes 94 degrees Celsius at Boulder, Colorado, and 72 degrees Celsius at Mount Everest. Why this happened? Yes, this is because all of these places have a different atmospheric pressure. Normal boiling point. What is the definition of normal boiling point? Normal boiling point is the temperature at which the vapor pressure of a liquid is equal to 1 atm. Boiling process. How the boiling process occur? Boiling process occur at the surface and inner part of the liquid, and you can see a bubbles. As the liquid is heated, the temperature is increased, and the kinetic energy and also molecular motion will increase. What happens next is the molecular motion becomes so intense and the molecules break free of the liquid and become a gas. At that temperature, the vapor pressure of the liquid becomes sufficient to overcome atmospheric pressure and leave the liquid to form bubbles inside the liquid. Bubbles of vaporized liquid form within the bulk liquid and then rise to the surface where they burst and release the gas. Okay everyone, that's all for today. Thank you.